Hi everyone, this is Gail Queen, and I'm doing a video here to help you with some of the conversions that you're going to see in week number 2. Some students tend to struggle with this, so I thought I would do a quick video. Well, I don't know how quick it'll be, a video to help you with it. All right, so first of all, they use some math terminology, and they use the word ratio. Ratio in math means fraction. So whenever you hear the word ratio or rational, you need to think fraction. So a rational number is a number that can be written as one integer over another integer, 3/4, 9/10, 2/3. These are all fractions. So ratio is another word for fraction. To manipulate a standalone fraction algebraically, we only have one option, okay? Our only option to manipulate a standalone fraction is to simply multiply it by a fraction equivalent to 1. So you've done this before. For example, if I take the fraction 1/2 and I multiply the fraction 1/2 by 5/5, what am I really multiplying by? 5/5 is equivalent to 1. We're really just multiplying 1/2 by 1. And so we end up getting the fraction 5/10. So what we've done is we found another way to express 1/2. 1/2 and 5/10 are equivalent quantities. And, we went from one to the other by multiplying by a fraction equivalent to 1. When we do conversions, we are going to be using fractions that are equivalent to 1, and we're going to multiply our current quantity times 1. It doesn't look like the number 1, it's going to look like a fraction. So keep that in mind. Okay, so here's the first example. Now, this is the first couple of examples I have here are what I would do if I were writing this out on paper, so you can kind of get an idea of how to do conversions to begin with. So the directions say convert feet to inches, and they give you 3 feet. Now, I know that most of you can convert this in your head, and you're pretty good with this kind of measurement, but the measurements we're going to be doing in the topic 2 work this week, they'll have tougher conversions besides feet to inches. So I'm doing an easy one to start you out to show you the process, and then we'll get more complicated as we go along. So let's say we had to do this easy one and actually write it out as if it were a harder one. What's it going to look like? Well, the first thing that you want to do when you're solving this is you got to get in your mind what you're starting at and what you're going to. I'm starting with 3 feet. I want to go to some number of inches. They want me to convert this into inches. So we start out thinking about conversion facts. I need the conversion facts between feet and inches. So most people know that 1 foot equals 12 inches. So these two quantities are equivalent. They're equal to each other. And that means that I can build a fraction that is equivalent to 1 using these two quantities. For example, if I put 1 foot in the numerator and 12 inches in the denominator, well, that fraction is equivalent to 1 because the quantity in the numerator and the quantity in the denominator are equal to each other. This would be like having 5/5, but I have 1 foot, I have different units, 1 foot on the top and 12 inches on the bottom, but it still is equivalent to 1. I could also invert the fraction and do it the other way, and we could put the 12 inches on the top and the 1 foot on the bottom. And again, the quantity in the top and the quantity in the bottom are the same, so that fraction is equivalent to 1. So every time you have a conversion fact, like 1 foot equals 12 inches, you need to understand that you can build two different fractions from that. You can either put the 1 foot on the top or 1 foot on the bottom of the fraction. So just know this is why the conversion facts are there. Every conversion fact you use in this project or in the projects this week, you're going to build fractions that are equivalent to 1 by putting one of the quantities on the top and the other quantity on the bottom. Okay, so how do I use this to help me? So we're going to start the problem by writing out the given quantity. It says convert feet to inches, and they start you with a given quantity, 3 feet. So write that down, and you're going to put it in this little table. And we're going to put the quantity that we start with in the top left corner of that little table. And the next section over to the right, we're going to put our fraction a fraction that's equivalent to 1. Now, you don't have to draw the little table there. I just think it's easier, and it's going to help you to figure out which fraction to use, and you're looking for units that are going to cancel away. So I usually write it in this little table format. Now, I'm going to choose one of these fractions to multiply by. I don't know which one to pick, so I'm just going to pick the first one, and we put 1 foot over 12 inches. Now, here's the thing. If I put 1 foot over 12 inches, so I am multiplying my original quantity, 3 feet, times a fraction equal to 1. So we're multiplying by 1. We're not changing the value of the 3 feet. We're just writing it in a different format. If we continue with this, what's going to happen if I multiply now straight across the top and straight across the bottom? So if I multiply straight across the top, I'm going to get 3 feet times 1 foot, which means I'll have 3 times 1 feet squared on the top. And when you multiply across the bottom, the only thing on the bottom is 12 inches. So my question is, if I choose to multiply by this fraction that I chose, do I get the correct units that I want? Here's the units for my answer: feet squared over inches. Did they ask me to convert feet to feet squared over inches? No. So I chose the wrong fraction. I don't want to use that fraction. Instead, let's choose the other fraction that's equivalent to 1. So if I choose the other fraction that's equivalent to 1, look at how nicely this works out. Now I have 3 feet times a fraction equivalent to 1. 12 inches is on the top, 1 foot is on the bottom. Now, the value of this is, do you notice how there are feet in the top by the 3, the units FT, and there are feet in the bottom by the 1, and these two are going to cancel. So this is why I want to choose the fraction with feet in the bottom so that the units of feet cancel away. They want me to convert the units from feet into inches. So they want the feet to go away. I need the feet to cancel out and go away. And I want inches to stay around. So now that I have canceled the units of feet, now if we multiply straight across the top, we will get 3 times 12 inches. On the bottom, the only thing I have is a 1, so that gives me 36 inches. So the unit conversion, do I get the units that they asked me to find? Yes, my answer is in inches. So now I know the answer is 36 inches. So 3 feet equals 36 inches. So all we did was we took our original quantity, 3 feet, and we multiplied by a fraction equivalent to 1. You're going to do this every time you do a conversion. You're going to multiply by a fraction equivalent to 1. You just have to choose the correct fraction. Okay, now some problems you just have to multiply by a fraction equivalent to 1 time. And on other examples, you may have to do it more than 1 time. So here's another example, example number 2 here. They want us to convert years into hours. So they want to know 4 years equals how many hours? Right? Now, do you happen to know how many hours are in a year? That's the conversion fact we would need. Years to hours. I don't know what that number is off the top of my head, but I do know I can convert in a different way. Instead of going straight from years to hours, I do know that 1 year equals 365 days. So I can convert from years to days. Now, 1 year equals 365 days. So I can build 2 fractions that are equivalent to 1. I can either put the 1 year on the top and the 365 days on the bottom, or I can put the 365 days on the top and 1 year on the bottom. You have the choice. There are 2 fractions that are equivalent to 1 here. So I'm going to set this up. Start with your original quantity, 4 years. Put it in the table and choose which of the 2 fractions you're going to multiply by. I'm going to multiply by 365 days over 1 year. Why did I make that choice? Do you see how the years on the top, the units of years appear on the top, and the unit of years appear on the bottom? So those units of years are going to cancel and go away. That's what we want to happen. I don't want years anymore. I want the years to go away. That's why we chose that particular fraction. Okay, now we are not done with the problem, because if I were to multiply straight across the top, I would be 4 times 365 days, and my units currently, where I am in the problem right now would be in days. They don't want me to answer in days, they want me to answer in hours. So now I need to convert days to hours. So do you know a conversion fact to go from days to hours? Yeah, we do. 1 day is 24 hours. So 1 day and 24 hours are equivalent to each other, which means I can build two fractions equivalent to one. 1 day on the top over, oops, that's a typo. That says 27. Obviously, I typed that wrong, so ignore that. That should be 24 hours there on the bottom. Sorry about that. Or 24 hours on the top and 1 day on the bottom. I just caught that typo. All right, so we're going to multiply by one of these fractions equivalent to 1, and we're going to choose the one that doesn't have the typo in it. We have the units of day on the bottom and hours on the top. So notice how you have days on the top for the unit and day on the bottom for the unit. These units will cancel and go away. And so now, if you were to multiply straight across the top and straight across the bottom, this is what it would look like. 4 times 365 times 24 hours. On the bottom, all I have is 1 times 1. So we just have a denominator of 1. When you grab your calculator and you multiply 4 times 365 times 24, you get a total of 35,040 hours. So the answer to this problem is 4 years is equal to 35,040 hours. So do you see how we just multiplied? This time I had to multiply by two fractions that were equivalent to 1. So every time we use a conversion, we're going to form a fraction equivalent to 1, either by putting the fraction, this way with a quantity on the top and a different one on the bottom, or we can flip it over and put the quantities inverted. You need to decide which fraction to use based on which set of units you want to cancel and go away. So I hope that that makes sense. Okay, now let's go to one that's a little bit harder, one that you will see, more like one that you'll see in your discussion question this week. Okay, this time I want to convert fluid ounces per kilogram to milliliters per pound. So they're starting us out with 25 fluid ounces per kilogram. So those are the units that I'm starting with, and I'm starting with a quantity of 25. They want me to change this over to some number of milliliters per pound. So we're going to start out by writing our original quantity. Now, one thing I will say, in the wording of the problem, notice how they write fluid ounces and they do the slash mark with the kilogram. Instead, write it like a fraction with a top and a bottom. So on the top, we have 25 fluid ounces. On the bottom, we have 1 kilogram. All right, so we're going to write it top and bottom. Now we're going to set this up and we're going to do the table because I know I need to multiply by a fraction equivalent to 1. And I'm going to put some quantity that's equal to 1 here. And I want to do this strategically. I don't know exactly what I need to use for the unit, for the numbers or the units here. We'll figure that out in a minute, but whatever I multiply by, I might need to multiply by 1 fraction equivalent to 1. I might need to multiply by 2 fractions equivalent to 1, maybe 3 fractions equivalent to 1. I'm going to have to step my way towards getting an answer that's in the format that we want. So what kind of format did we want? It said convert from fluid ounces per kilogram to milliliters per pound. So I don't know what numeric quantities are going to be in my answer, but I do know that the units that I want at the end of the problem are milliliters per pound. They tell me that in the wording. Okay, so that's what I'm going after. I've got to multiply by enough fractions equivalent to 1 so that my final ending units have milliliters on the top and pounds on the bottom. Okay, in order to get there, let's kind of think through how we need to get there. All right, so the first thing I notice is that for my final answer, I want milliliters in the numerator. So I need to get rid of the fluid ounces in the numerator. I don't want fluid ounces, so those fluid ounces, those units of fluid ounces need to go away from the numerator. What I want to appear in the numerator is milliliters. So my question is then, is there a conversion fact for fluid ounces to milliliters? So I need to look for that. I don't know it off the top of my head. Well, here's the deal. In your projects this week and the discussion questions, they're going to put a chart in the actual Excel file, and the chart's going to look something like this. And you scan down that chart and you're looking for, is there a conversion fact between milliliters and fluid ounces? And we go down and we find a row in our chart for 1 fluid ounce equals 29.5735 milliliters. So this is the fact that we're going to use. This is just the same. It's just coming from a chart, but it's the same thing as me having 1 foot equals 12 inches. This is 1 fluid ounce equals 29.5735 milliliters. Okay. So if I know that this is true, then I can form two fractions that are equivalent to 1. I can either put 1 fluid ounce on the top and the 29.5735 milliliters on the bottom, or I can invert the fraction and put the 29.5735 on the top and the 1 fluid ounce on the bottom. I'm going to use one or the other of these fractions that are equivalent to 1, and I'm going to multiply by my original quantity of 25 fluid ounces per kilogram. Now, keep in mind, what was our goal? I want the fluid ounces in the numerator to cancel and go away. So therefore, I'm going to choose the second fraction because the second fraction has the units, fluid ounces, in the denominator. When I put this fraction in place, you will see that you have fluid ounces now in the top by the 25 and fluid ounces now in the bottom with the 1 fluid ounce. And these units of fluid ounces are going to cancel. That's why I chose the fraction so that the fluid ounces will go away. All right, so I hope that that makes sense. So we chose from the chart the line that has the two quantities that I needed to use. I formed a fraction equivalent to 1, and I picked the fraction equivalent to 1 that has the right units so that the units I don't want cancel out. Okay, that's the strategy. Now, if I were to multiply straight across the top, I would now have an answer in milliliters. The only units in the top are milliliters. Yeah, that's right. But in the bottom, if I multiply straight across, I'm going to have 1 kilogram. And that's not what they want me to get. They want milliliters per pound. So I'm not done with the problem. This just means that I need to multiply by another fraction equivalent to 1. This time I need to strategize. So this time we're thinking about those kilograms in the bottom. I don't want kilograms in the denominator. I want the units, kilograms, to cancel out and go away. And instead of kilograms, I want to turn it into pounds. So the question is there a conversion fact between kilograms and pounds? So back to the chart we go, and you look at the very top row in the chart, and I see that 1 kilogram equals 2.20462, 462 pounds. So I can use this equivalency to build two fractions that are equivalent to 1. I can either put the 1 kilogram on the bottom and the 2.2 pounds on the top, or I can put the 1 kilogram on the top and the 2.2 pounds on the bottom. So I need to choose one of these two fractions in my problem. And remember, our goal was to have the units of kilogram cancel out and go away. So I'm going to pick the second fraction here and plug that in. And now I've got kilograms on the top of my fraction and kilograms on the bottom. These units of kilograms will cancel out and go away. And now if you look, I have, if I multiply straight across the top, what are the only units left in the top? Milliliters. You multiply straight across the bottom, and what are the only units left in the bottom? Pounds. So my answer here will now be in milliliters per pounds. I just have to figure out the numeric part of it. So here's what it's going to look like. Okay, if I multiply straight across the top, I will have 25 times 29.5735 times 1. And the units on the top will be milliliters. On the bottom, I have 1 times 2.20462, and the units on the bottom will be pounds. So you would grab your calculator, you would punch this in, and you would end up getting 335.358 milliliters per pound. Now they should tell you, if they actually want you to type this in and punch it in your calculator, then they would have to tell you how many decimals to round to. I just rounded it to 3 decimals, okay? All right, so I hope you can see how we're building these fractions equivalent to 1. From the chart, we're choosing our equivalencies, and then we're building the fractions, and we're just putting those in place to convert. Now, here's the thing. We did this. Let me go ahead and go to the next slide. We do have our answer here, but the question is, how do they want me to do this in Excel? What's this going to look like in Excel in my discussion question for the week? All right. So I need to figure out how I get this in. All right. So let's take a look. All right. So first thing that I want you to notice is I'm separating out. This is exactly the same as the previous slide. The only thing that I'm doing is I'm kind of separating the numeric part, and I'm moving it apart a little bit from its units. Okay, so I haven't done anything. I still have 3 fractions that I have that I'm multiplying by, but I have the number parts and then the unit parts for each one of these fractions. So let me make it even more clear. The number part for each fraction is in red, and its units are immediately after it in green. So there are number parts for the numeric part of the for ratio, and then there are the units for that ratio. And so everything we do carries a number and then a set of units. In Excel, this is what it looks like when you go to your Excel sheet. They're going to have something that looks like this. They've got a bunch of columns in Excel, and they have the initial quantity, the initial units, and then they say times, and then the next 2 cells, the yellow and blue cells here, are for the first numeric ratio, and then in blue they want the units for that ratio. And then we do times, and then we have our second fraction in yellow, the number parts in yellow, and then the units would be in blue. Times, if I had to do a third fraction, they have room for that, and it says equals. And here's my final answer. The final quantity, the numeric part would be in yellow, and the units for that final answer would be in blue. And these are exactly the color schemes that they use. Okay, so a couple of things to point out. If they gave me the same problem, convert fluid ounces per kilogram to milliliters per pound, and they start you with the quantity 25 fluid ounces per kilogram, then you would start the problem, and they already set up the problem for you in Excel. So the gray cells in Excel already have the given information in them. They're telling you that the initial quantity is 25, and they're telling you that the initial units are fluid ounces per kilogram. They already put that in for you. You don't have to type it in. So you don't have to type anything into the gray cells, okay? They also hold the multiplication symbol and the equal signs. So all you've got to do is fill in the ratios, those fractions that are equivalent to 1, and the units of those fractions equivalent to 1. Okay, so let's kind of look through this. All right, so here's my initial problem. This is how we wrote it on paper up above on top with our little chart. We're going to see how this fills into the Excel sheet. So the given ratio is 25/1, and the given units are fluid ounces per kilogram. This is already entered in the gray cells for you, as I mentioned. So then we go over to the first ratio. This is the fraction that we brought. This is our fraction that's equivalent to 1. This is the ratio that we have here is milliliters per fluid ounce. All right, so the red box has our fraction in it, 29.5735/1. That's going to go in the yellow cell, but don't type that in yet. The units, milliliters per fluid ounce, go in the blue box. But here's the catch. All right, when I go to do this, they don't want me to type the numbers in. They want me to type in a formula. They want Excel to actually do the calculating. I just have to program it to tell it what to multiply by, what to divide by, what to do. Okay, so that is the whole catch here. You have to use cell references, and you don't type in the actual number itself. All right, so let me get you there. So bear with me for just a minute. Okay, so remember that the conversion chart that we used is actually embedded in the Excel sheet. So first of all, let's look at this fraction, 29.5735 over 1. Where did 29.5735 over 1 come from? We did this just a minute ago when we were working the problem. So let me remind you of what we were doing. All right, so here's the slide we used. Remember how we were trying to get rid of the fluid ounces in the top? We want the numerator fluid ounces to go away. So we looked for the conversion fact in the chart. 1 fluid ounce equals 29.5735 milliliters. So we built this fraction. This is where that fraction came from. All right, so here's what we need to do. We need to look at this more closely in Excel. In this slide that I have on the screen now, I just pulled the chart over. But in your project for topic 2, you're going to be inside Excel working this problem. And so inside Excel, you're going to see this exact chart, but you're going to also see where it's positioned in Excel. So here's what it's going to, look like. I just again grabbed it, but I want you to notice that we will know the column that each one of these is in and also the row that these are in. So when I pull this out of my Excel, column B has the quantity with all of the columns of 1, okay, the quantity of 1 here. That's column B. The first units, now I do not know why they did this. They used 2 columns to get the units here. They used column C and column D to get the units. Column E has all of the equal signs in it. Column F has the conversion factors, the numbers here, and column G has the second set of units. So you can see the columns at the top, and then you can see the rows. Row 12 has the title headers, quantity of, first units, equal sign, conversion factor, and second units. And then the first row would be row 13. I say the first row. Row 13 would be the first row in our table here. Row 14 is the one that's circled in red. Row 14 is where I pulled the numbers to build my fraction. 1 fluid ounce equals 29.5735 milliliters. So we built the fraction that's equivalent to 1 by putting the 29.5735 milliliters over 1 fluid ounce. So we pulled this right out of the chart. We have 2 things that are equal to each other, built our fraction. Now I'm going to take this just to help you see the visual, and I'm going to kind of pull apart the number part of this from the units. So you can see that I've got the 29.5735 over 1, and then the units are milliliters per fluid ounce. In fact, we can even make it 2 separate fractions, okay? One fraction only has the number part, and the other fraction has the units. Now, look at where I got these numbers for my fraction. The numbers came from the chart. So the 29.5735 came from row 14, column F, and row 14. That's where I got my numerator, 29.5735. The number 1 came from exactly the same row. You have to use the same row for your conversion fact. So the 1 came from the cell row 14 and column B. So when I go to do this project in Excel or go to do this conversion in Excel, they do not want me to type in 29.5735 divided by 1. They want me instead to type in the cell references. So the cell references would look like this. 29.5735 came from what cell? Cell F14. So F14 goes in the top. That's where the number 29.5735 is. And the 1 came from cell B14. So I want to do in my Excel calculation, I'm not going to type in 29.5735 over 1. We're going to type in equals F14 over B14. So here's what it looks like in the Excel sheet. So for this first ratio, this first fraction that we have, if we worked it on paper, In Excel, in the yellow cell, notice how we did not type in the number, but we typed in the cell reference. Remember, when you type in a formula into Excel, you need to put the equal sign first. So it is equal F14 divided by B14. Now, in the cell next to that in blue, they want you to type in the units, and you actually type this in, ml divided by FLOZ, milliliters divided by fluid ounces. So they actually want you to type in the units there. So this is from my first fraction. Okay, I hope that makes sense. Now let's go over to the second fraction that's equivalent to 1. One more thing. Okay, so we typed in the formula. You typed in equal F14 divided by B14. When you hit enter after you type that in, Excel is actually going to calculate that quantity and it's going to put the numeric value there. So when you hit enter, you don't see your formula anymore. You see what Excel calculated. So you're going to see the 29.5735. Just know that if you go to that yellow cell and you type in the number 29.5735, it will not give you the green font telling you that you did it correctly. They don't want you to type in the number. They want you to type in the cell references. Okay, so make sure you pay attention to that. Okay, now let's move on to that second fraction equivalent to 1. Our second fraction equivalent to 1 is 1 over 2.20462, and the units for that second fraction equivalent to 1 are kilograms over pounds. So again, if we backtrack through our work, we can see where these numbers came from. Where did I get 1 over 2.20462? Well, it came from my chart again. We were looking for the fraction equivalent to 1, and I wanted the kilograms to cancel. So we ended up choosing the fraction that had kilograms in the numerator. This came from row 13 in our chart. And so notice that the numerator 1 came from the cell B13, and the 1 is in the numerator this time. So cell B13 will be in the numerator, and the 2.20462 came from cell F13. So the 2.20462 is in the denominator. So I put the cell F13, where it came from, in the denominator. So you've got to make sure that you put the numerator cell on the top and the denominator cell on the bottom. I have a lot of students that do this project or do the topic 2 discussion questions, and they accidentally type the cell references upside down. So just make sure that you're following and putting the cells in the right place. So for this second entry, we're going to put equals B13 divided by F13. And then for the units, we type in kilograms per pound. Now they have space for a third fraction equivalent to 1, but we did not need a third fraction. So this will just remain blank. You don't need it. It might even be grayed out in the problems where you don't need it. So we're just going to ignore that third ratio. And now we need to get to the final quantities. So I got to put my final answer in. And again, they do not want me to type in 335.358. They want Excel to do this calculation for me. So I have to type in a formula here, and then I will type in the units, milliliters per pound. So how do I get my final units? All I have to do to get the final quantity here is I just have to start at the very beginning, way over where we have the original quantity 25, and we're going to multiply the number 25 times my first ratio in that first yellow cell, and that's in cell D2. And then I'm going to multiply that by the second ratio, which is the second yellow cell there. And I just put that product in my final quantity. So this is what it would look like. We're going to do equals to let Excel know that I'm typing in a formula. We're going to do A2, that's where the 25 is located, times D2, that's where my first ratio is located, times G2, that's where my second ratio is located. I just need to multiply these three quantities together and I will get my answer. So you type that in equals A2 times D2 times G2. Now, these are the cells that I have on the screen right now. Your actual cells in your Excel sheet might be slightly different. You might be on a different row than 2. You might be in a different place on the sheet than ABC, right? So you need to look at the cells that have the quantities you want to multiply and use those cells, okay? All right, so I'm going to type that in, and when I do type it in, remember when I hit enter after I type in that formula, Excel will do the calculation, and this is what it'll look like when Excel does the calculations. So the only thing I can warn you about here again is that you are not typing numbers into the yellow cells. They do not want you to type in numbers. They want you to type in formulas with cell references, okay? All right, so I hope this gives you a little bit of a clue. It is a little bit confusing when you go into that Excel to do this problem, but I do hope that this video helps you. Shoot me an email, shoot me a message, let me know if you need some help, and I'm glad to help you out. Just let me know you want it, okay? All right, I'll see you guys in the next video.